What is the math behind harmonics? Have you ever wondered how music can evoke such strong emotions? The answer lies in the math behind harmonics. Let's break it down together. When you play a musical note, it produces a fundamental frequency. This is the main pitch that you hear, but there is more to it than just that single note. Alongside this fundamental tone, a series of higher frequencies called harmonics or overtones also sound. These harmonics are not random, they follow a specific pattern. The frequencies of these harmonics are integer multiples of the fundamental frequency. For instance, if the fundamental frequency is represented as F, the first harmonic would be at 2 degrees Fahrenheit, the second at 3 degrees Fahrenheit, and so forth. This sequence is known as the harmonic series. Now, the harmonic series is a mathematical concept that describes the sum of reciprocals of positive integers. In music, this series corresponds to the multiples of the fundamental frequency. The presence of these harmonics enriches the sound, giving musical notes their unique timbre or color. This timbre varies depending on the instrument or voice producing the sound. From a mathematical viewpoint, the ratios between these frequencies create consonance and dissonance in music. Lower harmonics have frequency ratios that correspond closely to simple fractions. For example, the ratio of 1 to 2 represents an octave, 2 to 3 represents a perfect fifth, and 3 to 4 represents a perfect fourth. These simple ratios are perceived as harmonious and pleasing to the ear. As we move to higher harmonics, the intervals become smaller and less aligned with the equally tempered scale used in Western music. This can result in sounds that are less consonant or even dissonant. Now, let's connect this to spiritual music and sacred geometry. The mathematical relationships found in harmonics are often seen as expressions of universal order and harmony in nature. The harmonic series reflects a natural pattern of vibration that connects sound to fundamental principles of balance and proportion. Sacred geometry explores similar ratios and patterns, suggesting that the math behind harmonics is not just a physical phenomenon but also a symbolic representation of cosmic harmony. In practical terms, this understanding influences tuning systems, instrument design, and musical composition. For example, the equal temperament scale divides an octave into 12 equal parts using a mathematical formula. This allows instruments to play in any key while still approximating the natural harmonic relationships. Musicians and composers can use their knowledge of harmonics to create sounds that evoke specific emotional or spiritual responses. By emphasizing certain overtones or intervals, they can craft music that resonates on a deeper level. So, the math behind harmonics is rooted in the harmonic series, where frequencies are integer multiples of a fundamental tone. These relationships form the basis of musical harmony and timbre, while also embodying a universal order reflected in both sound and sacred geometry. Understanding this math not only enriches our appreciation of music but also connects us to a larger cosmic rhythm.